now so it's on the record. Okay. Hi, this is Miss Litton, and this is 7th period with my wonderful AP biologist. Say hi.
Hi.
All right. Just a little bit of business. Your lab investigation 4. Try to have it done tomorrow so you can make sure if you have any questions. Sorry, I'm eating Tic Tacs. So rude. If you have any questions, you can ask me about it tomorrow, right? Or in the 7th period or something, so you're not emailing me at 10:30 at night the day before it's due on Friday, right? Also, then you have it all done, so when you have your holiday on Thursday, as long as you're not spending like 4 hours in temple, which you're righteously doing anyway, right? All of you. We should all go to temple, okay? I broke a window. Yesterday. What? Wow. With a golf ball. Yeah, it's going to be an expensive mistake. It was at Las Cosas Country Club. Yeah. Not at their club, but a house. Anyway, hi. Did you like swing it? No, I went over there and apologized. Villain. Okay. Do you like roller coasters? Anyway, come back to me. Sorry, I digress. I'm just so excited that we have good data. Okay, so your lab, try to have it done so then Thursday you don't have to think about it and it's all good to go on Friday. Questions, concerns about your lab? Okay, so let's talk content. Did you see my Instagram tweet, Twitter, whatever? What do you need to know how to do for sure? Water potential. Okay. So we're going to work our way there. I have a practice problem for you that'll get you good and ready for the quiz. I just want to go through all the big ticket items we need to know first, okay? So the first thing you want to get down in your head is the structure of a membrane. I personally, if I were you, because I think you have a essay prep question about this, I would be ready to draw it, you know? So I would be able to go like this and draw a phospholipid bilayer. I would have some intermittent proteins in here. This would be a peripheral protein, right? The membrane's going downhill. And here I have a bigger one. Do you see if you know everything I'm doing in here? Do you know what everything is? I want it to be green. Okay. Do you know what everything is on there? Yeah. Yep. Okay, tell me what is blue. Perfect. Could you tell me about regions of it? That would be what? And it would be what? Yeah, hydrophobic, and this would be hydrophilic. Okay. Okay, what is this right here?
The carbohydrate.
Carbohydrate side chain, good. If it's attached to a protein, it's called a glyco. And this would be a what?
Lipid. That makes sense.
Okay, and this right here would be a peripheral protein, right? And this would be a
integral. Did I get it? I got it.
Oh my gosh. What would this black be right here? All right, good. Next, let's talk about ways to cross. Okay. All right, what is one? I'm recording a presentation right now. Do you need me?
I need to ask about something about tomorrow for the test.
Ms. Chevalier is doing a review right now.
I have to go out for tennis, and I'm not sure if I should do the test tomorrow or.
Okay, can you come see me like at nutrition tomorrow at the start of nutrition, or be between 0 or something?
Okay.
Okay. What time do you have to leave for tennis?
1:45.
Okay, so you'll be able to do at least part of it. Okay. Can you come in early at lunch and do the individual part?
Yes.
Sweet. I will see you at lunchtime tomorrow.
Thank
Okay.
you.
All right. Okay, so what are the 3 ways to cross a cell membrane?
Carrier.
Yeah, that's what I wanted to hear. What are the 3 ways?
Through the phospholipid bilayer.
Right here, through the phospholipid bilayer. Let me do another. What's another way? Channels. Or what's a 3rd way?
Carrier protein.
Okay, no, that's not right.
What is
The whole membrane. You would either do endocytosis or exocytosis. Right?
I knew the motion.
Okay, now, if we're going to talk about through the phospholipid bilayer, then we need to use words like osmosis, right? What is osmosis? Has 3 parts to it. The diffusion of water across a semi-permeable membrane. Okay, so this part right here, okay, if we're talking about through a phospholipid bilayer, you could talk about osmosis, you could talk about hyper, hypo, iso, right? Tonic, all of those words, yes? You could talk about things like water potential. That's through the phospholipid bilayer. What helps water to move through a phospholipid bilayer? What is it called? Aquaporins. Good. Now here, if we're using a protein, if it's just helping us, but we're still going from a higher concentration to a lower concentration, what's that called?
Diffusion.
Oh, I need a word before it. Facilitated diffusion. Whoever said that over there. Facilitated diffusion. If it's going against the concentration, we would call that active transport. And the other type of active transport is endo and exocytosis. And if we're talking about endocytosis, we have 3 categories of that too, right? Cellular drinking is called penocytosis, okay? And then cellular eating is called phagocytosis. And then the other one, ting, 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 ting. Receptor-mediated endocytosis. Okay, now, do you want me to walk your brain through that one more time?
Yes.
Okay. So let's talk about the 3 ways to cross a membrane. You ready? Through the phospholipid bilayer using a channel or a carrier and whole membrane endo and exocytosis. If we're going through the phospholipid bilayer, okay, that is called diffusion if it's just like something moving from a higher concentration to a lower concentration. But if we're talking specifically about water, when we have water diffusing across a semi-permeable membrane, that's called what? Osmosis. Osmosis, when you're talking about water, okay? And then if we have a membrane separating 2 different contents, then we can talk about hyper, hypo, iso. That's all through the phospholipid bilayer material. If we're going to throw in a cell wall, then we're going to probably talk about water potential. And that's when we're going to talk about water potential and pressure potential and solute potential. That's all underneath the umbrella of through the phospholipid bilayer and water moving. Okay? Now, our second way to get across a membrane is using a channel or a carrier. If we're going with the gradient, no matter which one we're using, if we go with the gradient, that's called what? Facilitated. If we go against the gradient, it costs us energy, and that's called active. Okay? And the third way is whole membrane, endocytosis and exocytosis. If you use that method, no matter what, it's going to cost you energy, so it's called what? Active transport. And what are the 3 types? Penocytosis, phagocytosis, and receptor-mediated endocytosis. I'm so glad you're getting that on film. Okay. So do we get the big ticket? Okay. Then why do we have this stuff outside? It could be for cell recognition. It could be for junctions, etc. Now, side note, we talked about all the protein functions, right? I was just saying, hey, this is what we can do, how we can cross a membrane, but there are other functions of proteins too. So what were all the protein functions? Ready? Channels, carriers, cell recognition, receptors, enzymatic, and then cell-to-cell junctions. What were the 3 types of cell-to-cell junctions? Very, very tight junction, that's protein to protein, and then channel to channel was called a gap junction. And then you could connect the adhesion junction is when you're connecting the what? Cytoskeleton. Okay, questions or concerns about that? No? Okay, so when we look through, when we look at these pictures, this all makes sense to us when we look at the structure of it, right? And we know that it's called the fluid mosaic model because the proteins can move all around, right, within the phospholipid bilayer. We know that this region right here is always hydrophobic, and this region right here is hydrophilic. We know that cholesterol prevents membranes from freezing, right? But it also, if it's really hot, it keeps them all together. Okay, so that helps because one of those chains got a little bend in it. But you only find cholesterol in what types of cells? Animal cells. Good. Okay, okay. And collectively, the carbohydrate side chain is called the glycocalyx. Glycocalyx. Say it. Glycocalyx. Perfect. All right, so then we went through all the different functions, right? And you remember that. You could think of like an example of each of them, I'm sure. Enzymatic. And we did cell-to-cell junction. Now, who did we say couldn't go through the phospholipid bilayer if you were what? Large or charged. Why? Because of what area? Hydro what? Phobic area that you wouldn't be able to go through. So that's when you would have to use a channel, a carrier, or whole membrane. So then this is a good diagram to think about all of that, right? It's a good summary diagram. You good? Okay. And we talked about aquaporins too. Well, let's do this question. I don't remember what it is, but we'll do it. Today, I would like you to be the amount of hours you have of homework tonight.
24.
5,000.
Wait. Oops.
9,000. All of them.
Yeah, 600.
Oh, I'm glad somebody only asked 2.
I was like, what?
Okay, this one has a series of 9s, and this one has a series of 1s and 0s. That's terrifying.
Binary, yeah. Never ending. Binary.
Hey, you've got a binary code here. Okay, everybody in that's going to get in? Oh no, this is really super depressing. Tons and tons, millions, infinity hours. Infinity. There's not that many left in this day. Oh look, show questions. Well, that's new. Ah, now it'll be on the review. Wow! Whoa! That's new. Yes! And then I stop it and then we go. Oh, that makes me super happy. That hasn't always been there, right?
No.
Okay, that's what I thought.
Because then I can go back through and I can like
Yeah.
We were just at 100%.
That's because I switched to another question.
Oh, okay.
Yay.
Okay, varsity. Okay. Okay. Show live results. Okay, now back to overview. Now I'm going to quit it. Okay, thank you. Show questions. Okay, now with this new thing, I'm not 100% sure what to do. End. Here we go. Yay! We like that. Yay! Didn't even go. What did you say?
Joey didn't miss it.
Oh, good job, Joey. All right. So then I introduced signal transduction. So now you could have a, what is this? Receptor who starts a series of reactions, or it could even be enzymatic. Or you could have a receptor somewhere inside the cell, which then triggers a series of events. Okay, then we started talking about diffusion, and diffusion, and diffusion, and here's some more questions. Yay! Yay! Okay, start activity, show question. I'm loving that so much. A whole new world. Is that movie too old for you, or do you know that movie?
Wait, that's what I thought.
Oh, is that Aladdin?
No, it isn't.
It is Aladdin. It's just when she's like flying around.
Yeah.
Hyper. So it would be the cell is place. Is it the cell? Wait, what'd you put? I think it's B. It's just B.
Yes,
Oh,
you
because
do.
it's higher concentration. Wait, I should try. What is it?
Wait, that makes it so cool that I can go back and study.
Why are we not doing the first question?
We're just skipping it.
Maybe some people change their
Maybe.
Maybe someone just like disappeared.
Oh, dang it. What did I do?
It's the little side thing right there.
This? That's what I touched? Okay, thank you. I couldn't remember. Oh. Water? Doesn't it make sense to you that water would be the solvent? The solvent. You've heard of that before. Water's the solvent. Whatever you put into it is the solute. Okay?
water flows from
Okay, so if I make a beaker, okay. I didn't really think that's what I did, but all right. If I make a beaker and I put some water in it, and then I cut myself, drops of blood go into this beaker, okay? This is distilled water, okay? Let's make this double distilled water, okay? What, if there's a membrane, the membrane would be around my red blood cells, right? And that means inside the red blood cells it would have to be what? Hyper, and the distilled water would be hypo. Water must flow from the hypo. And it says the hypotonic solution contains the most solutes. No, the hypotonic solution contains the least solutes. Ask the person next to you if they get that.
I got you. Well, I got me.
Okay, now let's change it up. Okay, now, guys, can you ask me? So if I put a bunch of salt in here, very salty. This solution is what? Hyper. And my red blood cells are now, they are hypo relative to the solution. And it says when a cell is placed in a hypertonic solution, yes, water will exit the cell because the cell is hypo, water will exit. Water must flow from the hypo into the hyper. Okay, ask your bio buddy, do you get it? Remember this? You good with that?
I don't get this.
Okay. This would be a great little summary of the way water flows. Okay, you could take the same cell, but put it in a different environment, and you'll change whether it gets bigger or smaller, right? If I had carrots today at lunch. If I wanted wilty carrots, what should I have put them in? Salt water. Because the carrot would have been hypotonic to the salt water, and water...
Paloma Cortez to the counseling office. Paloma Cortez to the counseling office.
Water would have left my carrots. They would no longer have been crispy, rigid. They would have got all wilty because all the water would have gone out of them. If you just left carrots like from your fridge, instead you put those carrots like out on your counter, And as the air around it is going to have what? Higher or lower water potential? Lower. So water must flow from the hypo. Water would leave your carrots, and your carrots would start to get all bendy, right? But if I wanted really crispy carrots, I would put them in what kind of water? Distilled water. So the water would go in and fill all their vacuoles and make it rigid, right? Does that make sense? Okay. And then you could look at pictures like this in your book. There are several pictures in there. And then this brings us to water potential. Okay, so remember your equation. It is a pressure potential plus solute potential, right? And in our lab, we were eliminating the pressure by finding the molarity at which the potato would not gain or lose. So the pressure would be 0. So then all we had to do was take the molarity of the solution where it crossed 0, put that into our negative ICRT. And that's what you need to know how to be able to do, is to use that part of the equation in order to calculate the water potential. So when we look at something like this, why did the salt bother the snails? I know we didn't use this in our lab. But remember, you make a salty environment, water is going to leave the hypo slug or snail and go out to the salty environment, right? So it's always going to flow via water potential. So if here, you better, will you get the equation? Yes, click on the box. I can't.
On the quiz,
Oh, crap. So you're seeing it.
Wait, is that the answer?
Because that's what somebody, because they had to type it in. I'm not saying that's the answer. That's just what somebody put in. Because they're going to start to show what they put in. Ah. Whoa. 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 Remember, let's not celebrate our ignorance. I'm going to pause while students are working. Okay, and we are back. Oh. Did it give you your answer? Yeah. Okay, let's go over it. Okay, so what's your equation? You know your pressure. It doesn't give you anything about pressure potential, right? So it just asks you to calculate the water potential of a 0.6 molar at room temperature. So you're basically getting the solute potential, negative ICRT. Okay, so we got the negative part down. That's easy. Then what's the? Oh, sorry. I don't care. What's the solution that we have here? Sucrose. So I just told you this. If you don't know, sucrose doesn't ionize. So the ionization constant is just 1. What would be something I could use that would ionize so my concentration would be 2? Salt, because it's sodium chloride in water, so it would break up. Okay, now I need the C. What is the C? 0.6. So the C is the molarity, okay, that I'm looking at. At this point, it gave you the molarity. You didn't have to use a graph or anything to do that. So I'm at 0.6. Molar is moles per liter, right? We're good with that? Then this is a constant. The R, what's the R?
0.0831.
Liters per bar per moles per Kelvin, which I can't fit in here, okay? But it gives it to you if you're looking at this, right? And then the last thing is the temperature. Now, am I just putting in 22 degrees? No, because that was 22 degrees Celsius and it's 22 degrees Kelvin. So what do I need to do in order to get to Kelvin? 273 plus 22, is that right?
Yeah.
So 295. That's the number right there, is 95 Kelvin. And then all my units will cross off except what? Bars. So when you multiply all that out, what did you get? What did it tell you?
It's 7.4.
Which is not.
Oh, sorry about that. Sorry about that. Okay. Oh, that's why I was like, did it give you the answer, but it didn't go green? Sorry about that.
Yeah.
So you did it right. Yay! Now, let me ask you this. If this were a solution, and I gave you a beaker, and I put that solution in the beaker, and then I put a plant in that beaker. And what did we say this solution was? Negative, what, 14.7? And if the plant that I put in here was negative 3.7, think about what would happen to that plant. Think in your head. What would happen to that plant if I put it in that? Don't tell me out loud. Think. Let everybody think. Make a claim in your head. Give evidence and a reason for it. What would happen to that plant?
The plant is negative 3.7?
Yeah, the plant is negative 3. Remember, because what's 0? Distilled water. Okay, so we have a plant at this, and then we have this solution at negative 14.7. So think, what would happen to the plant? Now, I want to walk you down this. Who has higher water potential?
The plant.
The plant, right? Because it's not as negative as the solution. So if the plant has the higher water potential, is it hyper, hypo, or iso?
Hypo.
It's what?
Hypo.
Okay? Remember, the best possible scenario for water potential, best possible scenario of water potential is what? 0. You're never going to get a positive water. Well, just don't worry about that, okay? But as soon as I add anything to it, right, it goes negative. So minus 3.7 isn't as negative as minus 14.7, right? So I have a higher water potential at minus 3.7. Water must flow from the hypo. So it'll go from that minus 3.7 to 14.7. So what will happen to my plant? It'll shrivel. Does that make sense? Okay, it'll lose water. It'll lose water. So if I do it like this, okay, if I had a beaker, one more time, just think it out, and I put a plant in there, here is a big plant leaf. Okay, or a butterfly. Okay, what did I say this was? Negative 3.7?
Yeah.
It doesn't even matter. And this was, let's say this one out here is minus 10.2. Okay? Who has the better water potential?
The plant.
Plant has the better water potential. It is going to be the hypo, and this is going to be the hyper. Water must flow from the hypo. The vacuoles will shrivel. Okay? If instead I had a solution, this plant is 3.7, and let's say this water is minus 2.0. Now who has the better water potential? The water. And now this is going to have the higher water potential. This is going to have a lower water potential. So water must flow from the hypo. Water is going to flow into the plant. You all right with that? Okay. Now, I think I have something else in here, another review. We already did all the different types of endocytosis. We already reviewed that. And we reviewed this, right? Tight junction, protein to protein. Gap junction is what? Channel to channel, right? And then cytoskeleton to cytoskeleton was what? Adhesion. Good. Is there something right here? I know I put in another, oh, there it is. And I skipped over one, but these are new. I think I just wrote these. Or it.
Can we change our names?
This last, just a couple questions. Come on, we're okay with it.
Thank you.
You're welcome. Bye, guys. Do you feel okay about it?
Yeah.
Okay, good. You are welcome, Philip. Who are we FaceTiming in?
Drew.
Hi.
She said hi, Drew. He's waving.
Ask him, do you understand?
Drew? So, yeah.
Okay, good. We're good, we're chilling?
Yep. Okay, then do it.
You could. He could just go on to classlab.com.
Go on to class lab.
Duh, Ruth.
Don't tell me to chill out. I could end this.
Yeah, I could end this relationship. Boom.
I don't even know. How many hours of homework do you have? Actually, no, we changed it. It's your favorite pizza topping.
Hey guys, are you ready?
Can you switch to the second question so it's on there?
Can I what?
Can you switch to the second question so on the video it's on there?
Oh, the first one?
No, the second one.
Oh, there you go, sorry. I understand now. You totally get this. I went over this twice. What's this question?
I think a lot of people laughed.
Okay, yeah, so we'll go ahead and stop. Good. Okay, here we go. Oh! Okay, well, I'm glad we went over this because nobody's free. This would be this slide that I just jumped over right here about plant cell walls joined by plasmodesmata. A plasmodesmata is like a gap junction. Does that make sense? Gap junction? Okay, it's like that. It can pass through. And what else did we say here? Let's look at this. There's a stalker out the window. He's annoying. If he's one of your friends, tell him to get it together. Have channels between that allow strands of cytoplasm to pass from cell to cell. Can have lignin to add strength to our secondary walls. Do you see something in your notes about secondary walls? Or did I minimize that? I might have minimized that this year.
It's on the notes. But I don't
It is
think
on the
it's
notes. Okay, so right here, lignin strengthens it. I think we talked about that a little bit. Okay, let's hit your second question. Okay, good. 17 of you got that right. So it said in this order. So adhesion junctions share what? Cytoskeleton. Tight junctions share proteins. And gap junctions share what? Channels. Okay. Don't stress out about this one because I didn't ask anything about it on the quiz. So we can talk about that again another day. Don't let that occupy your time tonight. Okay. Any other questions or concerns? Are you good? I didn't even hear the bell ring. Did the bell ring?
No, it's 2 minutes.
Oh my gosh. I was thinking 3:05. Okay. Here, there's one other question I skipped over. I don't remember if it had a picture in it or not, though. We'll see. Oh, 4 questions. I was out of control here. Let's go. I'm going to go ahead and move to the next question. How many of you have done the first one? We're still not even to... Oh, because people have left? Okay. Okay, you ready? Okay, guys, I don't want to talk over you. If you need to talk, go somewhere else. This is, how do we not get this right? Follow the arrows. It's inside going out, I swear, if I see that boy again, seriously. That is exocytosis. Okay, yay, there's one. all of those are in endocytosis. Oh my gosh. Drew, was that you?
Probably.
Proteins are used in active transport, and pickles appear wrinkled because they lost water, right? So they must be in a hypertonic solution. Okay, love you very much. Make good choices. You're welcome.